Hello everyone, in this video we're going to go over Leetcode question search in rotated sorted array. Major tech companies like Amazon, Microsoft, LinkedIn, etc. are asking this question while they're conducting their technical interviews. I hope you will find this video useful for your technical interview preparations. Let's start with reading the question. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. We have an ascending array and it's rotated at some pivot point. So this 0, 1, 2 goes to the end. So 4, 5, 6, 7, then 0, 1, 2. This is the pivot point. You're given a target value to search. If found in the array, return its index, otherwise return -1. So we have a target value. For example, we are searching for 0. We need to return its index value. In this case, it's 4. Index number is 4. You may assume no duplicate exists in the array. Your algorithm's runtime complexity must be in the order of O log n. So the last part says we are looking for a binary search here. If the array is sorted and if it's asking for O log n, then it's most likely we're looking for a binary search in this question. If you don't know much about binary search, it would be a good idea if you learn binary search on Geeks for Geeks, YouTube, Wikipedia, etc. and come back to this video after. That would be helpful. So we have another example here. In this case we are looking for 3 and we don't have 3 in this array, so we return -1. Okay, so let me explain this on the whiteboard and maybe it'd be easier to understand. So we have a midpoint, and in a binary search we say high plus low divided by 2 to find the midpoint. In a shifted array, right, rotated array, we need to check if our mid is greater than the high, because in an ascending order array it should be ascending. Mid should be always less than high, but in our case mid is greater than high. So we need to find the minimum element either on the left hand side or right hand side. When we find the minimum, that means we have 2 arrays to search. It's the array on the right hand side and the array on the left hand side, and we need to figure out which one we are doing the search on. So here mid is greater than high. If the mid is greater than high, set the new low to mid +1. So this is our new low. Let's put it here. This is our new low. Then continue with the while loop. And we get rid of mid here. And we do the low and high again. Set the new mid here. This time we check if mid is greater than high. In this case it's a regular array. It's in ascending order, so we're not doing anything. This time we set high to mid. So we get rid of mid and set the high here. Then we do another while loop and this breaks. So we find the lowest element here. The minimum element is 0 and we found it. This is step number 1. We do the first step here. It's a binary search, but it's a twisted binary search. What we do is we check if our middle element is greater than the high element, because it shouldn't be greater than the high element. For example, in this array, this is in ascending order. We have a sudden drop here. then it's ascending again. So it should always be ascending if the array is regular. Now we find the lowest minimum element. That means we have two arrays. We can either search right hand side or left hand side. So that's what we're looking for. So what we need to do is we put the low back in here, we put the high back in here, and this time we have a min, a new variable here, min. So we found the minimum element. That's what we need. Now second step starts here. We have the lowest boundary 0, high boundary link -1, and the minimum element is here. We found the minimum element, so we know where to search for now. We are looking for that. Which part of the array are we doing the search on? So the target we are looking for is 2. If target is num's minimum element, so if target is greater than 0 and target is less than high, in this case this part, we set the low to minimum element. So this means we are looking for, we have an array here on this side and we're doing the search on this side. So we set low to minimum element. Otherwise we set the high to minimum element. It's in this case we set the low to minimum element. So we found the new low and new high, and the rest is very simple binary search. What we do is low minus low less than high, find the midpoint. If the midpoint is target, then return the midpoint. Otherwise keep searching. This is a regular binary search. All we need to do is, the first step, we compare the mid value to the last value, then find the minimum element, then set the lowest boundary to the minimum element. Then we know which part of the array we're searching, either right or left. Then we do the rest of the search. Let's do another example. This time we are searching left side of the array. Okay, this is fine. Let's search something. Okay, we can search 2 again, but it will be on this side. The array will start from here, so you will see the difference. So, step 1. Find the mid element first. We found the mid here. Low, high divided by 2, and that's the mid element. Is mid greater than high? We're checking. No, this is an irregular ascending order array. This is a regular array, so it's perfectly fine. High is greater than mid. So what we do is we set the high to mid. So we bring our high to here, and we get rid of the mid. So we have a new array in this order. Again, we check if we find the mid again, and in this case mid is this. This is our mid. So check if mid is greater than high. In this case, this is weird. This is not normal. Like the middle element is greater than the highest element, so this should be the highest in ascending order, but there's something wrong here. So low becomes mid plus 1. So we find the low here and mid plus 1. So we have low and high boundaries, and this is where this loop terminates. we find the minimum element here. Let's set the minimum element and set the minimum element here. Now we know which part of the array we're searching for, either on the right hand side or left hand side. So we have the minimum element low. Now we set the new low to start, a new high to the end, so this part is done. Step 2 is done as well. And step 2 is we set the new low to the minimum. Now we have a new low, new high. We are searching this part of the array. We are searching number 2, and it's on the right side. So this way we find minimum on the right side, and we will do a binary search on the right hand side and find the index number here. This is our index number. So this is pretty much how it works with the 3-step process. It's quite simple, quite straightforward. If you know the logic, it's very easy. And we check the mid number, then find the minimum element. We are always looking for the minimum because that will show us where 2 arrays divide. Then we know which part of the array we're looking for. There is another way of doing this with a single while loop, because we have 2 while loops here. In this way, what we do is we check start and end boundaries, find the mid element. If our mid is the target that we are looking for, we simply return it. So there's only one while loop. We are not doing the second while loop to find anything. We are not dividing the array into 2 this way. We are dividing array into 2 in one while loop. So nums start less than nums mid. We are looking for left side of the array. Then find the target in the start and mid value. Then set the new end to mid -1. Set the start to mid +1. If mid is less than nums end, that means we are looking for right side. Again, find the target between mid and end. Set the start and end values for the search, and finalize the search and return the mid. So in each loop we will check, and finally we will return the mid. We set end and start values on the right and left side and use it. Whichever is easier for you, you can use either of these methods. I think the first one, 3-step process, is easier to understand, but this is cleaner, and there's only one while loop here. This is I think this is better. So so this is this one, and this is the first one, step 1, step 2, and step 3. Let's submit and see what we get here. This works, and let's see this. This looks faster, but actually it both works the same way, and sometimes it does that. So you have 2 options here. You can either use that or this, and I think both works fine. I hope you found this video tutorial useful. I have other video tutorials coming up, so if you subscribe to my channel, we could meet again in the future videos. Thanks for watching. Goodbye.